lesson, you're going to be able to compute derivatives of inverse trigonometric functions. Specifically, these two right here, the arcsine and the arccosine. Now, the arcsine is really just the inverse sine. So whenever you see arcsine or arccosine, we're just talking about their inverse trig function of the sine and the cosine. So recall that y is equal to sine x, and if I want to make this into a inverse trigonometric function, if I follow the same steps as we did in a few lessons in the past, finding the inverse function for this would simply mean first interchange both terms, both x and y, and then you would solve for this new y. However, you just cannot do this. You can't divide by sine to both sides. You don't do that because sine is together with some angle. So the only way to get rid of this sine would be taking the inverse sine to both sides. So let me show you what that looks like. The inverse sine. Taking the inverse sine of sine. Well, the inverse of an inverse. These two are inverses of each other, and we know that when two numbers that are inverses of each other, we know that they either divide out or they become 0. So in this case, a sine inverse and a sine would just technically cancel out. Even though I don't like using that term, but I'm going to use it for this video. Those two will go away and leave me with sine inverse x is equal to y, which is pretty much what I stated up here. Okay, so now that you know what sine inverse is, it's just the inverse function of sine. Let's go ahead and talk about taking the derivatives of inverse sine. So I'm going to skip the introduction and some pre-cal work in this video because I want to show that in class. And I want to skip down to the derivatives because this is pretty much what you need to know for this lesson. So I have two new derivatives that I need to show you. The first one is the derivative of arcsine u. Now, u is a function of x. It says it right here. Let u be a differentiable function of x. So for example, I can take u to be whatever I want it to be. I can make it 2x squared, or I can say that it is a sine plus 2, or I can say that it is some sort of polynomial of degree 3. So u can be anything. The derivative rule for inverse sine u would be 1 over the square root of 1 minus u squared times u prime. So that is the derivative of inverse sine u. And I'm going to make a video of the proof for this. It's an intuitive proof. It involves a triangle. It involves a triangle, a right angle triangle. So I'm going to make a video of this, but only of this function, and then I'll leave you guys with to figure out the proof for this one for extra credit if you decide to take the challenge. The derivative of arccosine u is pretty much the negative counterpart of the inverse sine. So it's the same thing, but now it's minus. And I know that this is going to be a lot of rules to remember. You guys are probably thinking, well, sir, like we have so many rules to remember. I just want to give you guys a little trick that my younger brother had told me. He's taking calculus right now, and whenever you take the derivative of sine x, you get a cosine x. Whenever you take the derivative of cosine x, you get a negative sine x. Taking the derivative of anything with I've noticed that they're always negative. So for example, the derivative of cosecant. Sometimes we can get the derivatives mixed up. Just understand that the derivative of anything co would be a negative. I could even say cotangent. The derivative of cotangent is negative cosecant squared. And now you have a new derivative. The derivative of Arccosine is a negative compared to the sine. All the sines, I can show this, but I don't want my video to be too long. But if you do all the sine derivatives, they're all positive. So let's go ahead and talk about letter A. So letter A, the easiest way to attack this problem is to identify the u. What is the u in this problem? I'm looking at the u right here. Here is the u. So the u is 2x. U prime is 2. Now all I have to do is state the derivative rule. I'm going to highlight that in blue. State the derivative rule for this function. And it's 1 over square root of 1 minus 2x quantity squared. Okay. Not to be confused with 2x squared, because those two are different. If I square 2x, we know that it's going to be a 4x squared. So that's how students make mistakes. Those parentheses, you need to be very careful. Times the derivative of u, which is u prime, and that is 2. Rewriting this, 1 minus 4x squared. Our last example, part B, we have the derivative of arcsine of square root of x. Now, one more thing I want to note. I know I mentioned this in the beginning of the video, but sometimes in an AP problem or in your test, you may have it in symbols, sine inverse. So I just want to note that these two are the exact same. So our first step is to identify the u. The u is square root of x. However, square root of x is not very derivative friendly because there isn't a rule for taking the derivative of square root of x. I would have to convert it into x to the 1/2 so that I can use the power rule. Okay, just to recall, the derivative of x to the n is, you drop the n, you keep the x, you take 1 away from the power. So that means that my u prime, my derivative of x to the 1/2, is dropping the power to the front, keeping the x, and then taking 1 away from 1/2, and that'll give me a -1/2. Now usually I tell students to rewrite it, but we're going to go ahead and rewrite this at the very end. So we know that this is going to be a 1 over 2 square root of x. And the reason why we want to rewrite it at the end is because sometimes something may happen. You may have like some sort of like dividing out or cancellation. But these two mean the same thing. Now let's go ahead and let's go ahead and use the derivative rule. So that's supposed to be my equal sign way down here. According to the rule, it's 1 over the square root of 1 minus u, and u is square root of x squared times 1 over 2 square root of x. The final rewrite, if I take the square of a square root, we know that those two are inverses of each other, so that means that they will remove themselves. It's 1 minus x. Let me write that better so you guys can see it better. Square root of 1 minus x times 1 over square root of 2. I'm sorry, 1 over 2 square root of x. And if I do one final rewrite, I can multiply these two together because I am multiplying both fractions. 1 over 2 square root of x, 1 minus square root of x. Now, I know it may seem kind of like tedious of what I'm doing. That's the original answer. This is a rewrite. This is another rewrite. And the only reason why I'm going further and further is because on the AP exam, I don't know what type of rewrite they would want from you as a multiple choice answer. So I'm gonna go one more step. Okay, one more step. I'm gonna focus on the bottom. The square root of a number times the square root of another number is just equal to the square root of those two numbers multiplied. So I'm gonna go ahead and just write it like this: 2 square root of x 1 minus x. And I'm gonna stop right there, because I think that maybe that would be an answer choice on the multiple choice portion of the exam. Now, you could distribute the bottom and you get the same answer. They're all the same answers really, but I'm gonna stop right here, and I'm gonna say that maybe that's probably like the final rewrite that you would probably expect to see in an AP test. So hopefully you guys enjoyed the video, and hopefully that this video helped out with this lesson.